G'day everybody and welcome back to the channel. We're going to fix this, well hopefully fix it in this video. I went to use it the other day when I was working on an amp, the one I'm building. It was working, I was using it. I walked across the room, I came back, I picked it up, and as I picked it up, it went pop, bang, sparks come out of it. It didn't go pop and bang, it just went bang. Sparks came out of it and it popped the breaker. Now, I used to only have breakers in this house. Now I've got GFCIs, whatever you want to call them. So I've got a suspicion that it's not actually as bad as what it sounds like, and the heating element just popped and it sparked to the grounded casing and popped the GFCI part of the breaker. Obviously before I had GFCI breakers, if the breaker popped from an appliance, it was pretty detrimental because it would only pop from current. So we'll know when we get in there. Right, I just went to my spare parts or spare elements box. I had 3 or 4 of these. I must have had 3 because I've changed that element once, and there's one letter. Wait, that doesn't make sense. Maybe I only had 2. Anyway, you can bet I will be ordering elements. These are the original legit elements. I know where to get them from. Pretty easy to find. Alright, I'm going to get this thing apart and we'll see what's happened. Hopefully it's just an element swap as well. Anyway, I was using this and it went off with a loud bang, and I saw some spark sort of shoot out of this area here. And originally I was horrified because until a few weeks back I only had breakers in my house. So, and the power popped, the breaker popped when this happened. So I was thinking to myself, oh shit, this is triac controlled, op amp in there, there's only like a capacitive dropper or something. It runs off like high voltage half the circuitry in there. It's very crude, easy to self-destruct is what I'm trying to get at, especially if you shorted the output. So I was thinking, I was horrified. I was like, fuck, I'm going to have to change the LM393, the triac, half the diodes, half the resistors, probably a capacitor, the heating element, the wiring. Like I was imagining the whole thing was like black inside, you know. And then I thought about it and I thought what probably happened, because I'm not used to it now, I've got GFCIs on every circuit, is the heating element probably gave you up, and when it popped, it arced and sort of carbon tracked to this, which is earthed by this tab, and just popped the GFCI. So I'm hoping it wasn't a high current situation, because if it was, we've got a bit of a rebuild to do. If it wasn't, and it was just, you know, pop the GFCI because the element sparked to the grounded chassis, we've just got to change the element. So yeah, I literally just cleaned the filter out and emptied all the solder out of it, and I was putting it back in, and just as I rammed it in, the element went pop. That's why I'm suspicious, because when I changed the element in this thing, I swear I've changed it twice now. So I probably did have 3 in that box, yeah. When I changed it the last couple of times, I found the first time I changed it, I noticed part of the element, one of the element wires was still sticking out a crack. It was pinched, so I had pulled it apart and stuffed it back in. What I was wondering this time is, because it vibrates, it has a lot of vibration and heat. I know those wires are tough, they're silicon and fiberglass, but I was wondering, you know, did the wires rub out and short inside? Did the element pop? Did the control board go pop? Who knows? The thing is, the last couple of times the element popped, it didn't go off with a pop, it just stopped working. And I was in the room, so I know that. But the thing is, you know, elements do fail in different locations. The coil could have failed, you know, sort of in the middle and sort of sputtered the 2 ends of the coil further apart and just made an open circuit. It could have broken where it's a bit thinner on the ceramic and closer to the outside where the metal is, and sputtered to the metal and popped the breaker. So, I mean, you got to think about the failure mechanism of things to understand what potentially is going on, basically, is what I'm trying to say. Something else I'm going to tell you guys is these are amazingly good pumps. I've had this thing for about 2-3 years now, and when I bought it, there was a few different models you could buy. There was a lower powered one with a shit pump, a different, not a membrane pump, like a different style pump. And then there was the membrane pump, and then there was a double membrane pump, which is just stupid. This has got insane suction already. And something to do with the power level, I think, too. Anyway, I grabbed this, the s997p. It is just the more expensive model. Not the top one, but the one just below it. That's the best value for money, and in my opinion, the best model of this unit to buy. It's nicely done. You can see the pump mechanism in the back of it. It's quite beautiful. The only problem I had, you might be able to tell that I added some extra washers in here to pack this up, because originally when I got it, it was sort of offset. It's still offset a little bit, but it was really, really loud. Actually, now that's been running for a bit. Oh, it's because it's not perfectly straight. Yeah, that's as straight as I could get it with the washers in there like that. But yeah, you might have to add a couple of extra little washers in there to offset this straight so it's not vibrating. But, you know, everything is changeable on this. You can change all the parts, you know. It's nicely done. So you've got a filter in here. You've got a little stop thing in the bottom. You've got another filter in here. Alright. I've reused these filters and ripped them open and dusted them out so many times before I changed them. That's the other good thing about this thing. It lasts. It's good on parts. If you keep taking the filters out and sort of poking them and flicking them and blowing them and get all the stuff out of them and stuffing them back in there, you can keep reusing the filters for ages. And I've pulled this down and had a look inside here, and if I was wrong, that would all be full of soldered debris and there's nothing in there. So it truly, this is a really good tool, and it's a cheap Chinese one. That's the beauty of it. The only other thing I'll show you when we get inside, the temperature switch. There are two pots on the board. One's for the point that it cuts in and cuts out, and the other's for the set point, if that makes sense. So you can adjust it so that it really maintains the temperature really accurately, more than what you can with just like the 1 point of calibration in your general soldering iron base, if that makes sense. It's got 2 points of calibration. Like, that's what I'm saying. This thing's really good for what it is. S997PA. Highly recommend you guys go get one if you want a desoldering gun. As I said, they make a few different models, and I had a look at them all, and this is the one that's got the good parts, the good performance. I just highly recommend it. Hasn't let me down. The only thing I've had problems with is elements, and I think that's what's happened again. So that's supposed to happen, obviously. So literally nothing's gone wrong with it, hopefully, if all goods today, since I've had it. Yeah, so you can see what I mean. Look, even I had my green wire was crimped in there a bit, see? It wasn't. The wires are hard to stuff in there, you know? But that's how they go. Sorry about that. My phone was overheating. I had video uploading and blah, 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 and it was too much. Anyway, red, blue, green, element. You got your PTC and your element there, basically. So I can't see. Oh no. Oh no, my worst fears. It did happen. Oh, I don't know if you guys can see that, but that trace all the way down, it's gone. And I mean gone. Like, there's some of it. That's all just vaporized. There's a little bit of copper here. Got to remove the excess. Actually, could have been a veer there. Oh no, there was these little two solder points in a random spot. And there's what's left of the trace. And let's need to get a wire brush and clean that up with a wire brush, get some IPA, and then I'll put some lacquer on it so none of that carbon's there. That's the first thing I'm going to have to sort out. Alright. That can come off too. Hopefully that very, very thin trace blew, and they designed it to do that instead of taking out the rest of the circuitry, but with how sensitive semiconductors are. Yeah. I don't know about that so much. God, there's a whole load of flux on this. Better. Alright. Not giving it the craziest clean out, I'm just prettying it up a little bit, making sure there's nothing that can carbon track, all that sort of jazz. Alright, now, that's not good. The thing that's got a blown trace, that's not the heating wire, that's the PTC wire. Oh no. I might not be in luck. Well, I don't see any obvious signs of obliteration, which I honestly find quite surprising. This thing's very fiddly. I have been in here like 2 or 3 times, so I'm used to it, but it's still fiddly. I'm just going to screw that down for now because I don't see any signs of obliteration, but I'm still going to test that triac from the back of the board. I'm not going to test everything else on there. If the triac's not shorted, I'd say because it's the PTC side, something might have shorted going back to the op-amp comparator, whatever you want to call it. Like I said, I've got all those parts here, so it's not the end of the world. If I've got to fix the trace and change half the components in there, that is something that can be done. That's not right. Oh, man. Yes, I know, I'm lazy sometimes. I get the shits and I'm just like, ah, bugger it. That should be 380. Oh, bloody hell, I did it wrong again. Oh, now I just dropped something on the floor. The switch. Oh, okay. Yeah, right. Alright. So that little trace I'm still going to replace with something little, because it's obvious that obviously they know about this happening. Maybe when the element blows, it arcs over to the PTC element, and that's why they've done that, so it doesn't obliterate the circuit. It still obliterates the board for most people. So I've got to remember how you do all this. Oh yeah, I've got to take, I haven't brought it apart first. Dumbass. What was I thinking? Yeah, this is going to be impossible without ripping my hand apart. Oh, I know these are the wrong screws. They're the same thread. I'm just trying to get... Oh, I'm going to cut my hand. Ah, man. Why do I do these things to myself? Gonna have to put it back together properly. Disassemble it properly. Who would have thought? If I can just get 2 of these in all the way. Just like so I've got enough tensile strength on there. I'm not going to strip anything out. Grabbing it with my mitt and wrenching on it. Right. So now that's off, I can take that out. Bloody hell. Should just bring the jewel over here. Zip, 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 zip. But that's how you wear out threads. That's why I don't use jewels much. Okay, earth wire. Now this screw you got to be really careful doing up. I'll show you why in a minute. They don't supply you with a new screw. Right. And what you're doing it up to is that thin little tab. So you can imagine how easy it is to strip the threads and strip the tab. Turn my soldering iron on. As soon as I get the element disconnected, we'll power this up, turn it over and see if the light's on, showing that it's trying to fire the gun. We'll just have to see what happens. Might touch up a couple of those solder joints that I scratched. Scratching them has revealed that one or two of them are not the best joint. That's the least of my concerns right now, but the thing vibrates, so I don't want it to develop dry joints, and it's not like there's a whole ton of joints on there. I'll just tidy that up. Basically happy with that. Alright, there was a little bit of wire I wanted to trim. Don't like it when things are close to other traces. Ow, flicked myself in the face with solder. Alright, let's see if it's still alive. Well, I've turned it on and nothing's happened, but because of the triac circuit, it might need the heating element across it to actually be able to fire, if that makes sense, because it's a triac. And the light might be running off of that. Let's see what's happened to this. First, I want to know what my heating element resistance is. 181 ohms. Wow, that's gone up. A bit confused now. Let's see, do we short? It was the green wire. Maybe it's the green and red that's the heating element, but they're the thin wires and these are the thick wires, and these aren't polarized, so I don't see why. Alright, enough investigation. Doesn't seem like that's turning up very much. Feed these through. Oh, yeah. What length? That's the earth screw. This black plastic, it's very strong fiberglass reinforced plastic, and it looks like 40% or something, like you can see all the fiber in it. It's really good because you need to do these screws up ridiculously tight, otherwise the vibration makes stuff come loose. That's what I mean, they designed this thing well. Everything that you need to torque down, it's actually designed to be torqued down. I've been nothing but impressed with it. It is cheap, you know. what am I missing? Does that go straight in there? Yes. Just got to hook up my earth wire. Let me just... No, something's wrong. That goes in there. Yeah, that's right. Alright, earth needs to still go back a bit like that. And then back even more, yep. That's as tight as I'll do that because, like I said, there is about a thread, maybe a thread and a half if you're really lucky. So I usually route the earth wire sort of down there. Like I said, it's a bit tight in here, but with persistence, you can do this. Alright, heating element wires. There's a little sleeve passage for them to come out the bottom. And you want to also try not to let them rub out on that screw. So you want to sort of like get the curve on them a little bit further up, but not too far up, because your suction stem comes out of there. And then they literally go down there. And then basically just like that, back to your board. And yeah, they're like literally just the right length. I mean, they're Asians, you couldn't expect them to give you excess. There's already excess there. It's a miracle. Alright, that's that part sorted. So I'm just going to put the one screw in the other side to hold the heating element in place. A long screw or short screw? It's going to be a short screw. Yep. All right. I'll finish torquing that down tight afterwards. This goes like that, and you push it in there so that it's under that lip, and your tank will you can see how this will work when the case is on. So I'll give you guys a look at it. Alright, let's get these wires soldered down, and then let's come up with a solution for the missing trace. And let's make sure there's no more bits of wire that I dropped inside here before I plug in. Forgot to put the angle on the wires so I can get them on the board. That's better. You gotta be shitting me. How many times is that gonna hold its freaking temperature? Alright. I know that M1 looks a bit dry. It's not, it's just a coating on the top of it, so. Alright. We'll go get a little piece of wire or something to make that trace up. Alright, there's about as much copper in this wire as that trace. When I say as much, I mean it's probably like exactly the same amount of copper in this wire as what's on that trace. It's literally perfect for the job. It's like exactly the same amount of copper on that wire that's on the trace. There's a triac on here. I'd say that's a triac there, so that is the heating element. This isn't the heating element. I was going to say that wire's way too thin for a heating element. So is that trace. It doesn't make sense. Well, that's my bodge wire. Pretty good trace replica. Now, what I'm going to do, I'm going to use a bit of lacquer just to sort of glue the wire down to the board. Alright. Now I'm not worried about that vibrating around and stuff. If this still works and it's not blowing apart inside and I've got to redo the board. But anyway. Good, the wires aren't stuck. Let's just give it another test. Oh, that's not good news. She's dead. Alright. Well, now we know our circuit board's fixed. And we've got new elements in here. That trace blue, so let's try and work out what that corresponds with. So there's an LM358, BTA 406-600. I've got enough triacs like that. And then, what's this, an SCR? BT134. Isn't that a smaller triac? Maybe they're both triacs, maybe one's an SCR. I'm just going to test this little diac first. I've got them too. Not sure what its trigger voltage would be, but I can look it up and see. But I think they're all usually 90 volt. I'll give that another coat afterwards, but it's stuck to the board. I'm not even really worried if it's close to the other trace because it's insulated. That's why I used it. Got to sort that out too. What am I saying? It's not going to be able to detect that. It takes like 90 volts to fire. Having a silly day. Yeah, that transistor's getting weak. It's been bent up and down a few times. I'll flow some solder over the pins where they are thin at the bottom to strengthen it back up. Oh, it's not a transistor, you know what I mean. Might have to test these things out of circuit. Yeah, that's the temperature, the heating element, and this is the temperature feedback. So that's about to snap off literally. That is literally snapped. I'll sort that out afterwards. Not too worried about that. I'll leave it off for now so I can get to everything. Let's see if you can test this. I've got another tester too, on one of these out of circuit. I reckon the LM393's just gotten damaged because nothing else on here seems to be popped. I'll check those little diodes, but yeah, I don't know. I've got another tool that I know will test them, so let's give that a go. I thought it tested them. Although, you know, it could just be the threshold voltage or it's broken. There could be a number of reasons. That's all right. Let me go get some out the drawer and do a comparison on them. But I don't think it's going to be them. And here's why. It's the feedback side that the explosion happened on. I guess if it was enough to blow a trace, it could have popped one of these. So yeah, okay, we're going to have to look at everything. Luckily, I've got everything, so this is savable. I'll be back in a minute. Alright, I couldn't find one lying around. Plenty of BT134s, 136s, smaller devices, SC141s, all that sort of stuff, but couldn't find the larger ones. And I've got one somewhere. BTA 600 or something like that. Anyway, oh yeah, I want to have a quick look at the diodes. Looks good. Nothing wrong there. That's gone. Hard to say. That diode is a hopefully not a Xena with an unknown voltage. I've got a bad feeling it is, because there's got to be one in here, And that diode there says 4148 on it. That doesn't. My luck, eh? The unknown Zener. Yeah, that's definitely a Zener. That's why it's raised up too, because it heats up. Ah, oh, man. I'm going to have to take this out, see if I can read it. And if I can't read it, there is a board diagram for this thing online that I've seen. So you can order the whole board too. Worst comes to worst, it's only a couple of dollars. Yep, it's the diode. It's written on the board which way it faces, so don't worry, guys. And it says C225T down the bottom. Let me go see if I can find out what that is. I'm going to take a guess now that if the Zener's gone, the LM393 is gone, and everything else is probably good because it was the feedback side, but we'll see. I dare say if the Shrike had have shorted at the same time. Oh, these traces are thicker. Yeah. Only one way to find out. Alright, let me go see what I can dig up on this diode and the schematic if I can find it again, and I'll be back. Alright, well that was easy. It's a 22 volt Zener. I've got it in the next size up, so I'll go get one and a 393 and we'll get on with this. Alright, I actually decided to go with these little SMD diodes because these are probably only 500 milliwatt little mini things, if not smaller. So I'm just going to find the 22 volt. There it is. These are SMD. One of those. bit short. Just going to stick the old diode through the hole. Get its pin sticking out. Cut off the broken diode. Gone too close to the glass. I can't cut it without shattering it. Just put it in my... Good. And then I can bend this over. Like that. You can solder that. So now that diode's in there. Before I get the LM393, I guess we might as well just power it up again quickly. Oh, let me just... solve this problem. You should tins the pins first. Yeah, that'll make it a lot easier. Alright, now it's on there, I'm just going to thicken that up. Yep, I'm happy with that. That's not going nowhere. Solid. Alright, let's see if it works now. Nope. Let's just make sure the temperature's not turned down all the way. From me playing with the knob. Although no, it would still have to heat up anyway. Yeah. Alright. LM393. I guess. I should be able to get that out with that in there. Oh, bloody hell. Oh, this is just not going to come out, man. had soldered all the way through from the top to the bottom. Ah, man. Damn. I hate these situations. Try another technique. Now it's solder running out the front of it. This ain't going to come out. Don't ask. Alright, yet again, my phone overheated. Anyway, I think what I'm going to do is I'm going to try and get solder that's not going to happen. For those wondering, this is a counterfeit LM393, not a good one. I've got both. I'm sure the one that was in here was just a dodgy one. This is going to be very fun because I can't clear the holes out, so right, that's 1/2 in. There's a will, there's a way. Just need to get this back end in a bit. That might have to do. Oh no, we've got 2 pins that aren't in the holes. That's why I can't get the back end in. Got it. I hate doing that, but there's still one pin that's not in. It's in. This could be in further. These vias don't go through the boards, so these pads that have got traces on the top have to be soldered from the top too. Don't know how the hell I managed to pull that off. It's really hard when your tool that you use to do this stuff's broken and you got to fix that tool. Alright, let's see if it works now. Really? You know what's buggered? It's going to be a triax. Oh, did I damage that resistor? No, it's still alive. What's this guy? BT134. I've got one of those. I'll go grab one of those. Alright, I've got a BTA134. 600, yeah. That's another way of clearing out holes if you can't do it another way. Let's hope that this triac, because this is just a Chinese one, I did just pop one apart to have a look at the size of the die inside it, and it seems to be, let's go grab it. It seems to have a reasonable sized die inside it. We can pop this one open and have a look. Well, I might not, because I don't know that that's actually broken yet. But anyway, it's a Chinese one, but it's a copy, not a fake. So let's see if that yields any results. Still nothing. What? Where else could have gone? I've had a lot of luck repairing things lately. I mean, it just changed everything that could have possibly gone. I mean, 330 ohm resistor. You're going to be shitting me. Yeah, that's 1.5 meg. How would a 330 blow in series with a 1.5 meg? Oh, there's a trace that goes off somewhere else. Okay, because that 330 is in line with the thing that blew. Okay, that's fair enough. Yeah. If it doesn't work after this, I'll check the rest of the resistors, but other than that, God, I don't know what to say. It's definitely not a 330 ohm. Yeah, okay. That will stop it from working. I'll be back in a sec. Alright. I've even got the correct size of resistor. Oh, that's 32 ohms. Hold on a minute. Orange, orange, black. Gold, orange, orange, black. Gold, brown. This has got one extra. So is this a 33 ohm resistor? Hold on a sec. It's a 330 ohm resistor. I grabbed the wrong resistor. So I actually need orange, orange, brown. These are not in order. I'll just come back and pause the video. My apologies. Alright, I found the resistor. I know all the tricks in the book when it comes to trying to get stuff into spots with the wrong tools, because I grew up with the wrong tools. Seriously? we've got our 22 volt rail. The op amp's got its 22 volt rail. There's nothing across the 330. There's nothing across the 1 meg. You see that? That's gate. I swear that's trying to fire pulses. Oh, I'm on DC. That doesn't seem right. .39 volts on the cap. About 22 volts AC on the diac. Not quite sure what to make of this. I mean, that triac and diac are the only other two things I could think of on there that could not be working, unless that op amp's like fake and doesn't work at all. Yeah, I'm really not sure. Don't know what to make of it, guys. I'll have a look around for one of these. I can take the diode off the board. I'm going to go to bed now. It's getting late. This will just have to become a 2-part video. It's getting long anyway. I'll grab one of these. I've got vacuum cleaner, speed control boards and stuff like that I've got them on it. I've got a collection of diacs. So tomorrow we'll dig into that and hopefully I can get it back up and running. Otherwise, when I just order more elements, I'll just order the board. The board's like $15 and I'll just take back my components that I want. Like, I'm only going to take back that, the op amp and the Xena diode, to tell you the truth. But yeah. Anyway, that's all for now. I won't finish the video here just in case it hasn't been that long and I decide to finish this off in the morning. So yeah, that's all for now. I thought I'd just have a look at something else quickly. Yeah, let's still turn on. Well, I don't need that. Does the pump engage now? Yeah. That works. So what drives the pump is my question. Because what I'm confused about is why there's two triacs. Like, seriously. I think that's a 240 volt motor, not a 12 volt. Yeah, those windings are microscopic. That's a 240 volt motor. I'm almost certain. It could be a really small 775, but I'm pretty sure they got beefier windings. I'm just confused as to how it's driven. Maybe it's halfway rectified mains off this rectifier. But then what I don't understand is why is there two switching triacs? Okay, so this little one definitely does the heating element. That's odd. What the hell is this big one for? I don't understand this. Maybe they're using it to chop the mains up and make some sort of supply for it. But I thought they were just using a capacitive dropper and a Xena and... yeah. I don't know what to say. There's no more low value resistors on here. Oh, there's one. No, all good. It should stop at 68, 680. Yeah. Yeah, there's nothing else that's low. I mean, even that's not that low, but I still thought I'd give it a test. Oh, it might be a... yeah, 560. What's that other one? It's like 68 or 680. Oh, 0.6. Yeah, okay. So, yeah, I don't know what to make of this. Could try swapping the 393 again. Try swapping that. I don't know. I might just order another board. I've already spent enough time on it. It's like a $12 thing, you know. And I can always just keep this board for in the drawer for, you know, say the other one blows, I might be able to get enough off the both of them to make another one next time, you know. Yeah. I'll have a look tomorrow, and if I can find another one of these and find the value for that, I don't see why that would have gone. Unless this shorted to the gate and then took that out. But I'd imagine that it'd be more destruction, like the rectifier and other things. The diac would have blown open its passivated glass package. I think I'm just going to leave this, and yeah, if I can find one tomorrow, I'll do a quick video on checking those two components. But wait, does that test as a diode in one direction, or does it need the breakdown voltage to trigger in any direction? You know, it needs to break down voltage, I'm sure. Check it out quickly. So I think when you've got that many tools, you forget half the crap you've got. Current limits it as much as I can for this. Hmm? I think that's loading something in circuit. Let me try it the other way. And if that doesn't seem to want to go, then... Alright, so back on this. What I thought I'd do is clean up the op amp that I took off here and test it, see if it's actually broken or not. Just out of curiosity. I'm curious, the reason why is I'm thinking I might have destroyed this op amp, because I powered it up after changing that, but there was a 330 ohm resistor that was popped. Now the 330 ohm resistor is in series with a 1.5 meg resistor, and that goes off to the op amp, I think, the center point of that. So it's a voltage divider. Now obviously the high voltage would be coming in the 1.5 meg, and the 330 would go to ground, and off that center point tap it would be a very, very small voltage. But with the 330 open, it would have all of a sudden been a high voltage, and I reckon it went into the op amp and killed it, or comparator. But, you know, I don't actually know. So, also, I'm curious if you can stick one of these LM358s in an op amp tester. Actually, it's probably got a different pin out. I can't remember what the pin out is. Let me get the data sheet up on my computer, because I'm not even sure if this is a viable way of testing it. I just realised something. That it's an LM358, not an LM393. Guess what I've put in there? Yeah. Before we go and do any more component testing, I think it might be a little prudent of me to perhaps test this. And if it doesn't work, get an actual LM358, not a 393. I don't know what I was thinking last night. Ah, goodness. And I'll put a 393. I mean a 358 in there. This is actually making me laugh a lot. Let's see if this little guy's still alive. It's funny, sometimes they can be surprisingly hard to kill, other times they can be surprisingly easy to kill op amps. It just depends on the op amp itself and what you've done to it. Alright. So we have power. I believe that means it's dead. Let me take that back out. It's one of these Chinese sockets that doesn't have a little bit under it to... you gotta be shitting me. Come on, this is barbaric. Yes. Yeah, that op amp is shorted, I'd say. Although, hold on. I forget how to use this thing. That's the high frequency, that's the low frequency, that's your frequency adjust. Can't remember what this signal button does, but yeah, no, that's dead. Hold on, this is just funny. 1 second, see if I can do this. Look, it works. I'm joking. I'll go get another LM358 and put it in there. Hopefully that's all that's wrong with it. Hopefully, because I know I do have that triac or whatever it is. I can't find it. For the life of me, I can't find it. It's funny because I fixed a heater that's triac controlled. And I swapped the triac in it only to find that the triac was good. So I put the other one in a drawer here somewhere and I can't find it. So I know I've got one, but where it is beats me. Alright, well, I'll get this guy back out. This is going to be so annoying. I think I'm just going to take this back off to give me some room. I think I might take my time on it because now it's the second time I'm pulling it out and being rough. I will start to lift traces and stuff like that, you know. Can't believe I did that. Yeah, there is another way of doing it. You can always cut the IC out. I could always cut it out and take one pin out at a time. You could even cut it out and just solder the new one over the top of the old pins, but I'm not that dodgy. I think what I'll do is I'll take this component off, the triac, that I soldered its pins back together, and then I'll just get a Stanley blade and I'll just cut the pins on that and then remove them one by one and then fit an actual LM358. And I'll try and keep all these screws off to the side because they keep getting stuck to the magnets inside the permanent magnet motor. Anyway, that's kind of good news, I guess. I wonder what my other tester thinks of this part. Maybe I did this last night. Sorry guys, if I did, my apologies. I was really tired last night, clearly, because I put an LM393 in an LM358 socket. Anyway, let's see if this guy can test this. I've got a funny feeling I did test it out of circuit, but I can't remember. I remember testing them in circuit. That's all I do remember. Ah. Well, there you go. I just replaced a triac for no reason. You know what? I'm going to leave that in there though, because this is a guaranteed Chinese copy, but I opened it up and had a look at the die size in it and it looked right. So I know how many watts the element is. It's like 2200 watt or something. It's a lot of power, I'm pretty sure. Let me get the box. That doesn't sound right. Maybe that's my hot air gun. 80 watts, yeah, that's I'm not thinking. 80 watt element, right? 240 volts. That little triac is going to get hot quite quick if it's a fake one and the die's too small. The die looked right for the size of the part. I showed the die to you guys. I don't really feel like busting this one open because it's a genuine part and there's nothing wrong with it. And, you know, if that other one does run too hot or doesn't work or something like that, you know, at least I've still got this. And what happened to this pin? It's covered in solder and it won't come off. I was going to clean up these pins quickly because I can't get the solder off of it. That's better. Alright, I'm going to go get an LM358. I'm not going to do this on camera because it's going to take some time and the video probably already got quite long from yesterday. So I'm just going to take this out, take that out, swap it for an LM358, put it all back in, and then I'll come back and we'll see if it works or not. Alright, I know I said I wasn't going to show anymore, but I decided I'm going to do a better job on this. So I've taken the pins out of here. I'm going to reattach new pins to that. I've taken these wires off because these are small and they're getting bent, so I'll reattach them afterwards. Otherwise they're going to be about ready to snap off. And I managed to get the LM393 that I put in. It was only an Asian one, but it is brand new. Back out, which is cool because then I can test it, and if it still works I'll keep it, obviously. I don't think I would have broken it, honestly. I'll have to have a look at the pin out. Let me just have a quick look at the correct data sheet. Yeah, no, I don't think I would have broken it. I just looked at the pin out. It's the same pin out. The voltages on the input pins would be really, really small. It was only running off 22 volt rail. And like I said, it's the same pin out. So yeah, I'll keep this. Anyway, I'll go get an actual LM358, not a 393 now, and we'll see how we get on. Alright, I got the LM358 in there, and I've cleaned up the board so it looks nice and pretty now because I made quite a mess of it. So now I'm going to make up some pins for this using this, and we'll see if it works. Hopefully it does. I've also cleaned out the case and all the little solder balls and stuff because it's probably going to work now and I'm probably going to put it back together. So yeah, and if anyone's wondering why I'm not putting a huge amount of effort into this repair, it's a piss cheap Chinese gun. I mean, as long as it works, I don't care. Like I said, the board's like $12, $13. I should just be replacing it. So who cares? If I can bodgy it and it works, great. I mean, it's not even that bodgy, but anyway, I'm going to get some pins on this, get that on there. We'll see what happens. Guess what, guys? And you see that flicking? That's the triac firing. I just turned it on a second ago, so it's already almost up to temperature. But what should happen is in a few seconds, that red light should start flickering and then it will go out. And then every time it reheats, it'll sort of flicker a bit. It only stays on steady when it's heating up. We'll know if there's a problem because that will start to glow red hot, visibly. It basically glows a little bit red hot on the first warm up. It's like I said, it's a cheap gun. it just rams current into the element to heat it up, and it only fires pulses at it to maintain the heat. That's the way the circuit works. It's not the best circuit, especially when it's a 220 volt element on 240. It takes a beating heat coming up to temperature. If I turn the light off, you'll probably be able to see it. Yeah, you can. Hold on, let me turn the other light off. I've got to be quick with this because if it doesn't go out, I've got to turn this off straight away. But yeah, you can see that's actually red. See? And you see the light flickering. Uh-oh. That's not going out. No. That's not going out. Alright, hold on. Let's see. Oh, it just died. I think that just killed it. Oh no. Okay, so what's happened is we've got to do a recalibration on it. Yeah. So it's just trying to heat up way too much. I'd say that maybe the new op amp's got slightly different tolerances on it, or I don't know. I'm not going to claim to know how this thing works. It's a strange circuit, but I do know how to calibrate it. So we'll sort that out in a minute. I've just got to go duck up the road. Also, oh, does this still turn on? Also, I have felt the temperature on that and it barely gets warm, so I'll leave that in. I'll put that in my drawer. Good to know. The Chinese triacs that I got are legit. Anyway, I'll be back soon and we'll finish this up. Alright, I just watched back that last bit of video and something didn't seem quite right. I noticed the light was staying on steady, then flickering, then staying on steady, then flickering. Almost as if it's like, instead of pulsing to heat and then going off, it's like it's pulsing to heat and then going on, which makes no sense. I'm really confused. So let me work out. Where was the line? It's there. So I'll use the triac as my marker. So like that. So that's 380, 400, 420, in line with that pot, if that makes sense. All the way up 480. All right. So 380, it should. I don't get that. I can see it flickering, but I see it go on sometimes too. It's very hard to tell with the naked eye. On camera, it's a lot easier. Don't worry, I know that's live. I'm not referenced to anything. Ow. Actually, that is getting hot. I don't like that. I'm going to take that out and I'm going to put the original one back in and see if it gets as hot. I'm curious now. Sorry guys, but I just don't like that. Also, that could be what's screwing it up, because this circuit's so rudimentary and simple. I wouldn't be surprised how it works, you know, like you change one component on this and it throws everything out, is what I'm trying to say. It doesn't have like proper references and stuff like that, you know. It's dodgy as. It's all resistors and it literally relies on half of its own currents and stuff to derive other currents with resistive dividers and stuff. And It's very hard to explain, but I remember looking at this circuit once before when I had to learn how to calibrate it, and I thought, wow, that is just crazy. I'm going to take that triac out and put the original one back in. Alright, so I've got the original part back in again. Let's see what happens. I don't see any flickering. I just unreference myself from ground. You know what? That's still bloody hot from soldering it. I'm just going to wait a little bit and let it cool down. And I'll come back and then we'll test it again. I got a feeling that it just runs hot and that is actually a genuine part. The only reason I worry is because, you know, I've done all these AliExpress videos, and this came from AliExpress. Heaps of the parts, and it's got magnetic pins. Not that that means anything these days, but well, it does with some things. But anyway, a lot of these components are fake, and that came from probably a kit that was a mixture of fake and real components. So yeah, incidentally, I am spewing because I just burnt a hole there. It's kind of hard to see because I just did it. I just ran my pinky up against the end of that. It bloody stings. That's interesting. And that one gets hotter than the original one. I mean, the Chinese one. I shit you not, that runs cooler than that. Wow. I don't know what to say there. Although that is probably a Chinese copy too, so it's probably just that that's a decent copy and that's one of the shit copies. Wow, that's that hot I want to change it. Fuck. I'm going to change that back. Wow. Their Chinese triac is shit. The other one, I can't even feel anything. Okay, it's gone out. The light should just come on and start flicking and then going out and then coming on and then flicking and then going out now. I'm just getting a thermal, you know, aluminum chromal twisted together temperature probe. I can think of the materials, I can't think of what it's called. Bloody hell. I can't think of it. I just, you know what I'm talking about. A bit of aluminum wire, a bit of chromal. You make a junction at the end. Produces a voltage relative to temperature. Still can't think of it. I'm calling it a temperature probe. Anyway, let me just see if I can clean up the end of that and get some solder on it, and then I can get my probe in the wet solder. Essentially like taking a wet bulb reading. If any of you do AC, you know what I mean, and you know the importance of doing this. Well, it's not that far off. I've set it to 420. I mean, the thing only goes up to 480. Oh, shit. Okay. Calibration is needed. It's only supposed to go up to 480. I'm going to turn that off. Alright. I'm going to go online, find out the which pot's for which. I can't remember. There's 3 pots on here. I thought there was only 2. So I've got to work out. I think one of them. Well, now I'm confused because there's 3. I thought it was that one of them was like the point that it cuts in, and the other one was the point that it cuts out. But now there's 3 pots. I don't know. I'm gonna have to go have a look online. I'm also going to change that back to the Chinese one that I put in there, because that runs so hot I can't hold my finger on it. That, it just gets warm. I mean, the difference is astronomical. So I'll change that before I calibrate it, just in case it throws the calibration out a bit. And yeah, we'll be back. Sorry, this video is going to be a little bit longer than what was planned, but I mean, the thing did blow up, so what do you expect? It's practically a rebuild. Alright, I couldn't find anything on the internet other than the fact that these 2 pots, one's for the cut in and one's for the cut out. So I was right there. Doesn't even say which one's for which. And the 3rd pot, I don't even know what it's for. So, gonna have to do a bit of reverse engineering. So, I'm not going to touch the 3rd pot. It seems that's got something to do with fine-tuning its reference. So, it's something to do with the other 2, the cutting in and cutting out. Let me go get... Oh no, I'll put a little screwdriver here for the job. Cool. Will that fit? Yeah. Alright. Let's turn it all the way down. I have to work this out somehow. I know I have twiddled that pot in the past, but I probably spent like an hour testing everything with a multimeter and actually worked out how it was working. I just can't be bothered for all that today. Doesn't seem to be having any effect. And yes, I haven't changed the triac yet. Ah. No? No effect. Well, that's kind of worrying. What about this one? Not to make it, huh? The pot doesn't. Well, this isn't good. Hey, that's only 10 degrees off where it's set. Hold on a second. What have I done? I have performed magic somehow. Hold on. Let me just jam a bit of this solder in the nozzle and get the wire in there with my solder. Okay, I'm jammed in there. So now we can see what's going on and what these controls actually do. I'm really confused what this pot does because it doesn't have any effect and it's already set near at the end. That's where it was. Like that. And it heats up so much higher than what it's supposed to and then drops all the way back down. Put those pots opposite to where they were and let's see what it does. We'll work it out now. I've got a thermo probe stuck in a glob of solder on the end of it. So which one's the cut in? Ah, that one. See? Okay, so we set it 380. We want, it's already at 350, so I have to wait. I'm going to get it up to 380. All right, that seems like a good cut-in point. Now we need to work on the cut out. So I'll put that back. I'll put that in the middle to start off with. I think we're going to work this out. I think it is actually repaired. It's just out of cowl. Maybe it was already out of cowl. Who knows? I think I cowed it. I'm pretty sure. Yeah, no, I must have because that's how I knew the pots, what they were. So yeah, no, something's changed. But the circuit is working now. It's just out of cowl from the different parts, I'm assuming. Or different parts. Oh, I changed the Xena diode too. That could have thrown the voltage reference off a little bit. Yeah, and a resistor. You know what? Yeah. Yeah, I see why this is out. Okay, so that's dropped down at 330. This must get turned up a bit more. So we're getting there. Great, so I get my desoldering pump back in action because I need this. Wow, that's not bad. 40-degree overshoot. I think this is adjusting the cutout, so I'll move that back a bit that way more. I'll move it all the way back that way. You guys can see that, yeah? Oh, barely. Wow. I can't move that. There you go. Otherwise the thing will pop out my ever so expertly made wet bulb. Yeah, I play around with AC too. Build refrigerators out of scrap. I built a little bit, well, not refrigerators, I built one. I built a beer fridge out of scrap. Because I used to do scraps, I ended up with heaps of different compressors and stuff. And I had a little, one of those little box fridges that broke one day. So I cut a little radiator, attached fans to it, hung it in the top, got a bit of capillary tube, calculated the length, filled it up with propane and a little refrigerator compressor and made a beer fridge. It actually worked so well you could turn it down to the point that it was a freezer, so you could run it as a freezer or a fridge. I want to see that cut in. The cut in seems like it was almost right. Like I'm just turning that up in little increments now. I'm obviously doing this calibration down the low end. I mean, I need to see what happens when you turn it up all the way too, but we'll get there. Let's just get the cut in and cut out sorted out first. I have a feeling this pot here will have something to do with the reference for that. I don't know. Okay, so let me turn that all the way the other way and we'll see if that makes it cut out earlier this time. Because this is very important, not just for your work, so that you've got, a fairly usable temperature maintained at the tip, nozzle, whatever you want to call it, all the time, but also so you don't burn your heating element out. You don't want it just getting hammered all the time, Wow, man. I just can't believe that. Chinese run with a smaller metal area on the back. Gets less hot, but it does have a bloody nice sized die in it. I haven't pulled one of those apart. I've got genuine ones too, but I don't want to pull apart like the one or two only genuine ones that I've got. When I say genuine, like on Semi ST, something like that. I don't mind if it drops 20 degrees below and overshoots by 20, but no, it's going up a bit more. Let's see if it cuts out earlier now. I've got this pot, the cutout pot, all the way the other way now. Well, I think it's the cutout pot. I mean, for all we know, that's max temp and that's cutout. I'd say one's cut in, one's cut out, one's max temp. I could be wrong. Okay, that's not cutting out at all like that. Oh yeah, it did. That doesn't seem to make any difference. Hold on. That cut out at like 450, 460. I think 460. I've turned it all the way to the other end. We'll see if it cuts out any earlier like that. I think it did cut out earlier towards the other end, to be quite honest. The temperature control on this thing seems pretty shit, if you ask me. I mean, you guys are watching this, and I don't think it's because there's something still wrong here. I think it's just the way it is, Although, I don't know, because I would have noticed this when I first got it. Interesting. Anyway. 390. 380. Alright, so I've got my cut-in spot set. Let's see if it cuts out quick enough now. So I want it to already cut out. Doesn't seem to make a difference which way that pot is set in terms of cutting out. I mean, I don't want to waste everyone's time, but that cut out at like 460, and when it was all the way the other way, it cut out at 460. I'm pretty confused there. Unless that's max temp and that's cut out. So this is almost bottomed out that way. I'll bottom it out. We'll see what that does. So that's its target temperature, 380. Cool. I'm happy with the cut in there. I could bump it up a tad more. Yeah. That'll cut in bang on 360, maybe 362, 363, 20 degree TD basically between cut in and set point. Okay, so what happens if I move this pot that was almost all the way at the ends that I just moved to the ends, say, I don't know, 2/3 the other way? Because that's gone hotter. Oh, probably the same. God, this is terrible. Maybe that 330 ohm resistor I might have to tweak, because these are 1% resistors. And that's a voltage divider that's going to, yeah, the temperature. We'll have to look into that. I might have to tweak that value. The good thing about this is, as crap as it is, it's a simple circuit, so you can't like not figure it out, you know, without a circuit diagram and all that sort of stuff. Could be worse. Could be really complicated. You can't get a diagram for it. That could take days, you know. So let's see if it comes on at 360 if I'm right. Close enough, eh? Couldn't even hit 350. I'm happy with that. What I want to sort out cut out. Come on. I don't even understand what this other pot does. Did I cut out a little bit earlier that time? Hold on. No, it's... Maybe? Oh, I've got that pot that was all the way the other way almost. All the way the other way. It doesn't even seem to be making a difference. That's the scary thing. Just make sure nothing's getting hot with the pot bottomed out the other way, you know. This is quite concerning. Come on, we're all waiting. I might split this up into a two-part video. Calibration and repair. Well, that's cutting in where I want it. So I wanted to cut out like now. Here at the latest. God, come on. That does not make a difference. No matter where these two pots are, I'm going to put that in the middle. You know what that tells me? Something is still wrong in this circuit. Something isn't right. So, although it's working, I feel like the cut-in is working, but there's still something that's not working. I'm wondering if there's actually still something that's blown on here. Yeah, this is odd. Maybe the pot's got blown open. That's something I never thought about. That's a possibility as well. You know, one of these two pots could have the track evaporated. What are they? I'd have to get it out to read it. Anyway, let me clip my clip lead. Let me put my clip leads on the multimeter, and then I'll clip onto something that's adjacently parallel with the pot and see if the pots work. So that pot goes to that pin, and that goes to where you can't get to it, which is just wonderful. Looks like it's actually in parallel with the other pot. Can't be. Ah, so that's interesting. That pot there is in parallel with the track on the temperature set pot. Ah, so this is the max temperature set pot. Okay, we're getting somewhere now. Now it was over here. I'm going to put that in the middle for now. So now we know what that is. Alright, so that must be our cut-in, cut-out pot. I swear that didn't make a difference where it was. Hold on a minute. I am not going to say I'm not confused. That would be a complete lie. Alright, I've got my little... wet bulb arrangement. It's a bit hard to get the solder in the end with the wire, but I think I got it. Hold on. Think isn't what we want. I just can't get it in now. I'm just gonna have to do it like that. Bloody hell. I'll pause the video and try and sort this out. Alright, I ended up getting it in there. I'm 99% certain that there is solder inside the tube with my temperature probe. I'm just going to leave it. I can see smoke coming out from inside. But yeah, that's jammed in there with solder. Yep, cool. Alright. Let's see if we can work this cut in, cut out stuff out now. So I assume that max temp pot, I don't know, let's not assume anything. So I'm going to set this, I'm going to turn that all the way down and that all the way up, and I want to see how much it overshoots 480. Ah, not bad, we've worked it out. So the cutout does actually go about there. I mean, the max temperature where it was correct. Yeah, I'm happy with that. We are making progress. Interesting. I'm having trouble getting this right. I'm going to play around with this off camera and then come back. I think I've got it worked out. Alright, I've worked it out. So I basically just about got it fine set how I want it. Remember these two were sort of like one that way and one that way. Well, now they're sort of facing in a little bit more. So one pot that way a bit, the other pot that way a bit. And I remembered what this is for. It sets the speed on the motor. I remembered that was a mod I did when I got it. It comes a little bit low. If you turn it all the way up, it's too much for the motor and it's very finicky. And the fine spot for me turned out to be right there where it was. So I'm setting it back to that. Anyway, I've got it set for 420. It's always got about a 40-degree TD. I thought it was 20. It's 40, but yeah, it's cutting in, it's cutting out. I am more than pleased now. So I'm going to put this back together, and I finally got my desoldering gun working again. I'll turn that off now. And obviously I got to unblock the nozzle, but yeah, it's repaired. So I'll put it back together now, give you guys a look and end the video. And just in case you're wondering, that's what it looks like with the board back in. And yeah, I put a little bit more lacquer in here. This wire is covered in lacquer where it mates with the board so it won't move around in there. But anyway, ta-da. Alright, that's it. And yeah, I left the original Triac in there. You know what? It's run in there for like 3 years without popping. I'm just going to leave it in there until it pops. It is a dodgy, cheap Chinese one. I mean, if my cheap Chinese one has got a bigger die and heats up less, it's not like it's a transistor. It's got, you know, it's a BT134. That's going to be legit, and that's the shit one. But anyway, it's alright. It's not that hot that I can't hold my finger on it, but it's not, you know, I wouldn't personally run components that hot. But anyway, so it's back together. Got my desoldering gun back. About time. Also today I ordered 3 elements for this thing. So with the one that's in there, I now have another 3. Hopefully the next time the element fails, the PTC doesn't short to the element and fry half the circuitry, because the last couple of times I've blown an element in this thing, the element just popped and I had to put a new element in. This is the first time it's been a destructive failure. But anyway, that's it. So I'll end the video here. Thanks for watching everyone, and I'll see you all soon.